First things first, I would like to extend my thanks to these 3 people. Without them, I would not have been able to make this discovery, and I would not have been able to make this such a refined, simple, easy process for anybody to follow and apply to their own creations. So to these 3, thank you very much. The links to their socials or whatever they choose will be in the description below. So make sure you show them some support and check them out. So to start this off, you're going to want to make sure that you are using Blender version 4.5. If you're on Steam, that's as easy as right-clicking it in your library, going to Properties, Game Versions of Betas, and scrolling down until you reach version 4.5 Stable LTS. Alright. If you're not using the Steam version, I'm sure you have the knowledge to simply look it up. Blender 4.5 in Google. Download it from there. Next, what you'll need is MCBlend, which you also just look up and it'll be right there. You open it. If you don't know how to install a plugin, you open this GitHub page, go to releases down here, scroll down a little bit to the right, and download this. From here, you will open Blender, go to File, no you won't, you'll go to Edit, Preferences, Add-ons, click on this little arrow, Install from Disk, and you click on the mcblend.zip file that you've just downloaded. And then you enable it with the little checkbox on the left. From there, you're ready to get started. Right here in Blockbench, I have a GeckoLib entity model. Alright, this is just a model I whipped up for something completely unrelated back when I was first figuring this out. If you already have a model you're using, that's great. One thing I have to make note of is that during this process, you don't have to do this. I'm not sure how much of a difference it'll make in the end for some animations, for some models, but in my experience, if you don't move your child groups, if you have like, let's say for example, this arm that I have right here, which is my bicep and my forearm, and I have my forearm under the bicep to make the entire arm. If I keep this like this and then animate in Blender and bring it back here, for some reason, with the way that Blockbench animations work with their quote-unquote armature and their pivot points, it'll look a bit funny. There is a small margin of error. I'm not sure how large that margin of error can get, but it is there. So if you want one-to-one quality exporting from Blender back into Blockbench, you're going to want to select everything that's under something else, right-click, move to, and I would suggest having a root folder that stores the direct folder of everything else. So now I have nothing else. Oh, would you see that? My torso. Move that to my root folder. And there we go. Everything is directly under one folder. Nothing is inside the other. From here, you will want to go to File, and you don't want to export it yet. MCBlend works with bedrock models specifically. And thankfully, there's a button in here perfect for that, which is Convert Project. You want to convert your project to a bedrock entity and confirm. Now you will have this, which is your project just in bedrock format. Then you'll go to File, Export, Bedrock Geometry. Let's give it a normal name. We'll just do thing bedrock.geo.json. Alright, and now we have that file and we can go to Blender. And now that we have MCBlend, you can make sure that MCBlend is installed by seeing it right here on your little panel thing. Alright, you'll go to File, Import, and now at the bottom you will have Import Bedrock Model, which as you can see I have a bit of a history with this, but we'll just use the one that I just made and import it. Now we're here and you can see the truth behind Blockbench's armature system. It's kinda wonky. Alright, thankfully this isn't what we're working with technically. I'm adding this in post. Make sure you absolutely do not edit the armature structure or the model of this import. If you touch any hair on its body, the moment you export, it's going to be all over the place. So you want to make sure you keep this just as it is. From here, what you want to do, go to Object Mode, select everything, hold Shift, press D, and now you have a duplicate, which it doesn't matter where the duplicate is, so we'll kind of move it a bit out of the way to make sure it's on its own little space. From here, we're going to make the inverse kinematic armature. To do that, I'm no Blender professional, so the way that I do it may not be as efficient as some of you know, and if you know a better way, go ahead, but all that needs to happen is that this right here corresponds to the bone that you have selected. So this is arm L2, which for me means this is my forearm for this. So we're going to start our bone making right there, extruding on the start point of the bone, the large end and not the pointy end. We'll extrude that down, and we'll do the same over here. It's my lower torso, so I'll also go down. It would make sense for this torso to be connected and extruded off of that one, but every new bone that we make needs to be directly connected to its corresponding Blockbench bone. So that means the torso needs to be its own bone, and I cannot just extrude from the torso. To make the lower torso, we need to extrude off of the lower torso bone provided by Blockbench. And now lastly, we will do that with the head. And there we go. So now we have the new rig inside of the Blockbench provided bones. From here, we need to start the parenting game. So what I mean by that is we need to start parenting all of the original Blockbench bones to the new ones that we've created. So we'll select our Blockbench one, hold Shift, and click the new one, hold Control and press P, make parent, keep offset. And we'll do that for all of these. Control P, keep offset, boom, 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 bang, bang. Just like that. And now we have that done. So that means when we go to move one of the new bones, it will move, there we go. It will move the old one, which will in turn move the model. Now obviously this isn't connected to the other bone, and that's an easy fix. All we do is go back in edit mode, and now that this bone, the new one, is the parent of the Blockbench provided one, we can then parent that to the other new bone to properly connect this rig. Just like that. And then we will connect everything to the torso in my scenario. Boom. And so now if we go into pose mode, moving the shoulder, moves the entire arm, moving this, moves the forearm, moving the torso, moves everything. The head stays connected, this is here, and that's there. Alright, now we have to make the inverse kinematics. For now, since we have all these connected, we don't really need the old bones right now. So we can select all these and press H to hide them. When you're done hiding your bones, you can hold Alt and press H to unhide them. But we'll keep them hidden for now so that we can set up the inverse kinematic rig. For this, we'll make sure that all these line up. I'm not sure if that truly matters, but just in case. Okay, everything's positioned the way I would like it to be. And now it's time to make the inverse kinematics. So for that, again, I'm just doing it the way I learned off of a 3-minute YouTube tutorial. So if you have a better way of going about this, then go right ahead. But this is how I learned to do it. So here, I just made a mistake. These are made off of the endpoints of this. the forearms. So when we go to make the poles, which are what control which way the elbows will bend in this scenario, we don't want to make them based off of the endpoint of the shoulder bone. We want to make them off of the start of the forearm bone. And then we'll do that. All right. And for your IK controllers, which are the new bones you just made, you will select everything, hold Alt P, clear the parent. And for my elbows here, we'll just pull these a bit out, and these will be the poles that act as controllers to tell us where the elbows want to bend. And for my rig, that's all we need. Nothing else needs inverse kinematics for me. So now we will start making changes. Also in pose mode, we can get rid of these for the time being. If you've noticed, this original Blockbench bone has stayed. This is our root. Well, this is the pivot point for where I've set my root. This doesn't need to have a new bone. You can obviously make one if you want to. I don't see the point, but if you would like having your own bone so you have a clean structure, then you can just keep this as is. But now let's set up our inverse kinematics. The way we're doing that for my model is as shown. Select your new rig's bone, add a bone constraint. This will be the button all the way on the bottom right here. The bone going through whatever that little oval is. Add bone constraint, inverse kinematics right here. Then we'll add 2 chain length because we have the forearm connected to the shoulder, which makes 1, and then connected to the torso, which makes 2, which allows the torso to move the shoulder and the forearm. We will then select our target, which is our armature, and then the bone that controls the IK, which is this bone. Now we have this set up. All right, so we can select this, and we can move it, and there we go. We have our inverse kinematics. You can leave it at that if you're comfortable with that, but if you have something like how I have it here, which is an arm that clearly has an elbow that needs to be pointing in the correct direction, then you can have a pole bone, which when you do that, it might mess up. So what I've learned to do is just full 180, and now that's as it should be. And now when I move this around, I have no idea what I just did. And now if I almost did it again. If I move this around, as you can see, the elbow of the model will point towards wherever this bone is. So now if I move this up here, you can see that is pointing towards the pole. And if I move this over here, it'll point over there towards the pole. So that's how you can control that. And I will now set up the inverse kinematics for my other arm. And there we have it. My rig now has inverse kinematics. I can move it around any sort of way I like. And now the root, which will serve as the master control for this entire rig. As you can see right now, if we try to move it around, it gets stopped by the constraints of the inverse kinematics. To fix that, all we need to do is go back into edit mode, select our IK controllers, and then lastly shift click the root bone and then parent with offset, which is Control P one last time. Now if we go to pose mode, boom. Our root now moves the entire rig. That is our master control. And now we're all set up. We have this arm can do that, this arm can do not that. That arm can go there. These can change where the elbows go. And now we have our 2 rigs. We have our IK rig and we have our original rig. Right here, right here. So what we need to do next is we need to unhide all of these bones in edit and in pose mode. Unhide all of these bones. Now go into object mode and select both the rigs and go back into pose mode. What we need to do now is add something called a copy transform bone constraint. The reason we have to do this is because with the way IK movement works in Blender, these bones aren't getting transform data. And transform data is how you make keyframes. So if I were to do, here, we can show this real quick. If I open my animation and we select everything and insert the keyframes, if we move this, if you're wondering how I move the armature and then a keyframe is automatically placed based off the movement, it's because I have this little button on the bottom right here enabled. When that's enabled, whenever you move some sort of armature piece, it'll record that movement and immediately make it a keyframe for you. And we go here, you can see that it's still 0. So if I move this over here and move that back down, as you can see, we do get keyframes on the, it's highlighted right now, we get keyframes on the inverse kinematic controller, but we do not get keyframes on the arm itself because it is receiving 0 actual transform data from the movement of the IK rig. This is what we're fixing by having 2 rigs and using copy transforms. What we'll do is select both rigs, go into pose mode, and one by one, alright, there's a fast way to do this that I was shown, is you can select the duplicate bone first, and then shift click on the original, hold Control, hold Shift, and press C, copy transforms. After you add your copy transform constraint, you want to go down here to target and set that to pose space so that your arm stays there, or your bone or whatever you have will stay there. And there we have it. All of our bones now have a copy transform constraint to its corresponding duplicate. What that means is that now when I move this bone, as you can see, the original armature moves with the transforms of the duplicated bones. This doesn't seem too different from just having it on one rig, but the reason we have to do this is because for some reason, and obviously if anyone knows a way to make this easier, then go ahead and contact me or leave it in the comments. But for right now, as far as I know, this data that I talked about before does not get recorded to these bones. Even right now, it shows that it's not there. But now that this exists, the copy transforms, it technically does. Blender refuses to acknowledge that transform data is being made with the changes. But once you have a copy transform constraint, it now has a reason to acknowledge the fact that transforms are being made with these bones. Even though they're being manipulated by inverse kinematics, the transform data is being recorded, and it doesn't show it here, but it is there, which I'm unsure as to why that is. I think it's kind of silly and stupid, but this is what we have to do to make this work. Now that we have all this set up in our pose mode, that is the last time we'll ever be touching the duplicate bones up here. So we can hide all of these large, obnoxious ones, and we have our clean rig and our original rig. So we can move this and do whatever we want. Next, we can start animating. But first things first about animating. For MCBlend, the way MCBlend works is it uses the difference between your resting pose, which is the pose you exported out of Blockbench, and the new pose. So for frame 0, you're going to want to press A and I, which will insert all of your keyframes for this pose on both armatures. Frame 0. Then you can just scoot over to frame 1, select your new rig, and get to animating. And here we are. This will be our first frame. As you can see, if we go to frame 0, it's our resting pose, and then frame 1 is the start of our new animation, in which we will just have something simple. And there we go. And with this process being the way it is, we can actually apply any sort of interpolation or easing mode that we want. So here's our animation. Sorry. There we go. And because frame 0 is our resting pose, when you're playing your animation, you might get that little clip of your resting pose. If you want to see your animation without that, you can just set this as frame 1, and now you have your looping animation here. We'll set that back. And this is our complete animation. And if you look down here, it's being perfectly mimicked by the original armature from Blockbench. So the next thing we'll do, so we'll go back to object mode, select our rig, which it will have no keyframes. Don't worry about that. We don't actually have to worry about this one's animation here at all. We'll just bring that down, and on the right side of your screen, under this little panel, you'll see all these widgets. You want to go down here to Object Properties, scroll down, and look for McBlend : animations. You'll select a new animation. You can name it whatever you want. I don't actually know where that goes when you name it, but right here, extra frames. I haven't read all this. I don't exactly know what it does, but it's sort of similar to if we were to go into pose mode, select everything, pose, animation, bake. We have this menu which says our start frame is 0, our end frame is 81, and our frame step is 1. What our frame step means is that, as you can see, I'll select OK real quick, but don't do any of what I'm doing. This is just to show you what this means. Frame step is going to be a sort of division multiplier so that we can optimize how many frames our animation has. So let's say I optimize it here because it's a simple animation and nothing much changes from me dimming down the amount of frames I have. So that can be a way to optimize file space. If you have too large of animation files and you want to cut them down a bit, you can change that value. And I'm telling you this because when we go to our McBlend animations down here in extra frames, it's sort of the same menu as what we just saw with the baking frames. But here instead we'll type things manually. We have our resting pose on 0, but 1 is when the actual animation starts. So we'll type 1 right here, and then the next number divided by a colon, no spaces, just the colon, will be the steps. So if you want every frame to be keyframed with no optimization or cutting, then keep that at 1, and that'll be your 1-to-1 quality. All right. And if you put that to 2, then it'll divide your keyframes in half. Right now, I don't really care for how many keyframes I have, but just for example, I'll put 2, and we'll have a few less keyframes. And then divided by 1 more colon will be the end of our animation, the amount of frames that we have overall, which right here, as you can see, is 81. So I will put 81. Now for the rest of these buttons, you can read up on them if you'd like. Whatever helps you, whatever makes this a better experience for you, or works better for your setup, you can finick around. There is a document about all of the things that McBlend can do. So you can read up on that if you'd like to know more. But for now, we'll just have this as an interpolation will be what you have in Blockbench. These are your 3 Blockbench interpolation options. I'm just going to leave it on auto. And then from here, we're ready. So we'll make sure we're in object mode, have our original armature, only the armature selected. Go to File, Export, and down here you'll see Export Bedrock Animation. We'll we'll name it something sensible, like just test1 for now, .json. And we can export Bedrock Animation. Now with that, we can go back into Blockbench, go to Animate, and this button up here is the Import Animations button. We'll click on that, and we will use test1, open. And there you have it, your animation in Blockbench. If you'd like to see the keyframes, you can click this button right here, and this will show all of your keyframes for this animation. And now you're probably not working in Bedrock, or if you are, good for you. But if you're working in GeckoLib like me, it's as easy as this. File, Convert Project, GeckoLib Animated Model, Confirm. Now if we go to Animate, our animation is here in a GeckoLib project where we can which File, export GeckoLib model, GeckoLib animations. And there you have it. If you're having any trouble, any questions, or if you discover something that makes this entire process easier, go ahead and leave it in the comments, contact me. Any way that we can make this process more user-friendly, I would love to hear. But once you're used to it, it's a whole lot faster, your workflow will get a whole lot easier, and you'll be able to animate with a program you're more familiar with and use your experience and talent in Blockbench for your Blockbench projects. Next, I will show some footage of how to import textures from Blockbench into Blender so you can animate your model with textures in Blender.